Friends, today we are going to discuss a very important characteristic of paint which is which need to be known thoroughly to determine the dye film thickness and wet film thickness of paint, and what is the quantity of paint required. What is the quantity of paint required for cover a certain area. Before going to discuss, we want to tell, we want to know what is volume solids. We know that all paints are made up of resin, pigments and colors, additives, that means are like a stabilizer, antifoams, thickeners, we are adding additives and solvents. And after this is the paint, the consists of these items. But after paint is applied, when we apply the paint, the solvent evaporates. We know what are the solvents. Now water solvents or oil solvents. Water solvents evaporate quickly. Oil solvents evaporate slowly, leaving only the dry solids. Dry solid means resin, pigment, and additives in the form of a continuous coating. In the form of continuous coating. So solids can be expressed. So those solids, this solid is left continuously coating. The solid can be expressed as a volume percentage of entire volume of the can of paint, of the can of paints. How much solids are there in the can of a paint. For example, the solvent takes up half of the paint volume. If the solvent takes water or oil takes up the half of the paint volume, then one can say that the paint is 50% solid, 50% solvent, 50% solid. One can therefore expect that if wet coat of paint is applied to a wet film thickness, when wet coat of paint is applied to a wet film thickness, wet dye film thickness 100 micron, then after drying, what will be the dye paint thickness? 50 micron, because 50% the solid thickness. So what is the percentage volume solids? What is the percentage volume solids? Now dye film thickness divided by wet film thickness into 100. So for a product when applied had a measured wet film thickness of 100 micron, after the solvent had evaporated, left a dye film thickness of 50 micron. So suppose 50 micron. So what will be the volume solids? Now percentage volume solids will 50 divided by 100, dye film thickness divided by wet film thickness into 100, that is 50%. So but we rarely need to calculate the volume solids because all the paint manufacturer in their product they mention the product data sheet what will be the volume solids. So by knowing the volume solids, very important, knowing the volume solids, we can calculate theoretical spreading rates. 1 liter how much area will cover. Wet film thickness, WFT, to deliver the required dye to what should be the wet film thickness. If we know the solid volume solid, then what will be the dye film thickness? So if you know the dye film thickness, then what will be your wet film thickness? That can be calculated if you know the volume solids. And if you add thinner, then your thinner weight, and then you have to recalculate the wet film thickness and dye film thickness and percentage of volume solids. So these are the if you add thinner, then your volume solids will change accordingly. Your wet film thickness will change to maintain the dye film thickness. So it is very interesting to know the volume solids. Now, relationship is I have told you, the because solvent evaporate as the coating dries, so wet film thickness will be greater than the dry film thickness. So what is to determine what wet film thickness required to achieve a specified dye film thickness, to because dye film thickness is very important to protect the steel parts or the bare parts. The manufacturer will tell you that this much thickness, dye much thickness is required. So how much wet film thickness we have to apply so that to get the required dye film thickness. For that we want to know. So dye film thickness is equal to wet film thickness, WFT, volume into volume of solid divided by 1000. So what will be the wet film thickness to get the required dye film thickness by into volume solids by 100. For example, if you require a dye film thickness of 50 micron and your product is having 50% volume solids, then wet film thickness will be how much? Now 50 into 50 dye film thickness is 50 micron and volume percentage is 50 micron divided by 100. So 100 will be your wet film thickness, because 50 by 100 it is 2, and then it will be 100 micron. Now, relationship between spreading rate and volume solids. What is the spreading rate? Mean how much paint, how 1 liter paint, how much area will be covered, and your volume solids, the relation is there. So if you have the volume solid value, if you know the volume solid value, know what is the dye film thickness you require to protect the metal paint which are going to will be painted. You can calculate the wet film thickness needed to be used if you know the solid volume solids. So how? Now wet film thickness will be dye film thickness into 100 by volume solids, by volume solids, percent volume solid. So spread rate will be how much per liter, how much meter square will be covered, that is the volume solid, percentage of volume solid into 10 by DFT required. How this formula, this 10 into volume solid by DFT has come, that will explain now. So 1 liter paint means 1000 cc of paint, that is equal to 1000 cc that is volume. So WFT means wet film thickness into area, that will give you the 1000 cc. So what will the spreading rate will be, what is the spreading rate? A is equal to 1000 divided by WFT. So the WFT and percentage volume solids means so A is equal to 1000 by WFT. Acha, volume solids is equal to previously we have been dye film thickness by wet film thickness into 100. So wet film thickness is equal to how much? Now wet film thickness is equal to dryness factor, wetness film is equal to volume solid into volume solid into wet film thickness is equal to, here it will come here and it will come there. So dye film thickness divided by volume solid thickness divided by percentage of volume solid. So if you put the WFT here, WFT here, so it will be how much? Now that it will be WFT put here, then volume solid will come up. That is 1000 volume solid divided by 100. So it will be 10 volume solid into 10 divided by DFT. So this formula is generated. You see both the formula, how this formula has come. Now by this the formula has come. For example, suppose a steel section needs to be coated 125 to protect it, 125 micron DFT of Duramax paint, GPE, with which is 71% solid or 71% volume solid. So what is the wet film thickness required to get 125 micron? Now that wet film thickness is equal to, wet film thickness is equal to, we know 125. We have previously we have seen the percentage of solid, that is wet film thickness is equal to DFT into divided by volume of solids into 100. So you see the DFT, wet film thickness, will be DFT into divided by 71 your percentage or solid volume into 100, that will be 176. So if you apply wet film thickness 176, you will get 125 micron DFT. 120 micron DFT. And then to achieve this wet film thickness, what should be the spreading rate, area for per liter of uh, paint. So that we know, the formula we have know, that is this formula, volume solids into 10 divided by DFT 125, volume solids into 10 divided by DFT. So here it is, what is the volume solid? Now volume solid is 71 into 10, that is 710 divided by 125, that is 5.7 meter square per liter. So in 1 liter we will get how much? Now 5.7 meter square area we will get, where we can apply WFT how much? Now WFT 176, then 17.5 meter square, and then we will get 125 DFT plus 5.7 square meter per liter of paint to get 125 DFT. So spreading rate will be, that is 1000 divided WFT, that is with this also you can calculate with this formula, or with this formula A is equal to 1000 divided by WFT. A 1000 divided by WFT is how much? 176, that is also 5.7. So either you use this, or if you know the WFT, then also you can calculate the how much liter of paint is required. I think you can understand everything. Now, effect of thinner. Sometimes we are using thinner to dechoke the spray nozzles or increase the area of paints. We are using thinner. Often we use thinner. So when we are using the thinner, certainly your volume solid percentage will change. So what will be the new when you are using thinner? What will be the new corrected volume of solids? Now earlier volume of solid, it was mentioned into 100 divided by 100 plus thinner. How much thinner you have added? So corrected oil film thickness is equal to, so that will be your new volume solids. New volume solids is earlier volume of solids into 100 divided by 100 by plus thinner. How much thinner you have added? That will give you the new corrected volume of volume solids. Now what will be your wet film thickness? Now dye film thickness into 100 plus thinner divided by solid volume divided by volume solids. That will give you the wet film thickness. The formula we have already learned. So example, if we are apply Duramax GP paint with a volume solid of 71%, same thing, and dye film, to get a dye film thickness of 125, after adding 5% thinner, what will be the then you have to calculate what will be the new volume of solids. New volume of solids will be earlier volume of solid at 71 divided by into 100 divided by 100 divided by plus 5, 105, that is new. Now new corrected volume of solids will be 67.6. Earlier it was 71. As you have added 5% thinner, so your solid volume will come down. Then wet film thickness, dye film thickness into 100 by corrected volume of solids. So wet film thickness, how much you have to apply? Now 185 micron to get 125 DFT. Earlier it was how much? Now earlier it was 170. Earlier it was 176. wet film thickness. Now after adding the thinner, you have to maintain the wet film thickness 185 to get 125 dye film thickness. Dye film thickness. This is the formula. And spreading area will be how much? Now corrected volume of solids into 10. That formula we have already mentioned by DFT. That is your corrected volume solid is 67.6 into 10 divided by 125. That is 5.4 meter square per liter. So it will be 5.4 meter square per liter. Per liter. If you add the thinner, earlier it was 5.7. Coverage area was more. Now your coverage area has come down. Now per liter will only when you using thinner, because your DFT has come down, because your weight, because your percentage of solid has come down. That's right. Spreading area also come down. That is 5.4. Earlier it was 5.7. The very important thing. Now estimate the paint requirement. Similarly, paint requirement also. How we will calculate the volume of paint required? Now we know 10 into area into dye film thickness divided by volume volume solids into divided by into 100 minus wastage. So suppose your wastage is you are while you are pouring the paint, there is wastage is 10%. Then for to get the dye film DFT 125 micron, volume of solids is equal to 60%. Volume of solid 60%. From the graph, we get the theoretical value spreading is 4.8 meter square per liter, and now and estimated paint required. If you from the graph also you can calculate, as well as from the formula, 10 into 4.8, that is your 4.8 into 125 divided by 60 by volume percentage solid volume into 10% is your wastage. So that will give you 1.11 liter to cover 4.8. Earlier it was per liter, it was covering 4.8 meter square. Now to cover 4.8 meter square, you require more paint, that is 1.11 liter to cover 4.8 meter square of area. So because your percentage, there is some wastage, and for this much cover, this formula we know, and 4.8 into 120 micron, the percentage volume, your weighted volume solids into waste. It is now, it will come how much? Now 1.11 liter is required to cover 4.8. Earlier 1 liter you can cover it. Now your coverage requirement of oil paint will be more. You see where is the dye film thickness. The tables are also available. You see for the percentage value 50%. If your specified dye film thickness is this much, so what will film thickness? 100, double. If you 60 dye film thickness, then what for 50% volume it will be 120. And so the graph is also calculation is also table form is also available. Similarly, here also you can come to know the spreading rate when your volume percentage volume. These are the percentage volume volume solids. This is the DFT. So what is the meter square per liter? Now you can come to know. For our case, you can see 125 DFT, and your new it is 4.8, 60% for solid volume solid. Our requirement will be 4.8. 4.8. You have seen in the previous, it is 4.8. 4.8. You see the previous reading, that is the 4.8. You see the per liter, it is also available in the tabular form. Here also you can calculate directly in the tabular form. You can also directly calculate, and with the formula also you can calculate. That is the spreading rate is equal to 10 into volume solid divided by DFT required, or A divided by WFT. WFT. There also you can come to know. You see the corrected volume solids, that the volume solid into 100 divided by 100 plus how much thinner we are adding. Thinner, suppose your original volume solid is 50%, percent of thinner you are using 10%. So corrected volume of solid will be 50 into 100 plus this much, this, that is 45.45. 45.45. Earlier it was 50. When you are adding 10% thinner, your your corrected volume solid will be this much. Your this much. So your weight film thickness will be more. Earlier it was 50%, 100%, 100 DFT, WFT to get 50% DFT. Now you have to add more DFT, more than 100 DFT, more than WFT to get 50 DFT, 50 DFT. So you can see original solid volume solid is 50%, and then percentage thinner you have to add 10, that is equal to 45. You see here it is all calculation also, it is coming 45.45. Here also you are directly getting the percentage of you are getting percentage of thinner, percentage, this is a percentage of thinner. Then after this one will be your new volume solids, new volume solids. The tabular form is also available. Also available. So this is very important to know the volume percentage, it is called volume solids, to calculate your wet film thickness, to get a new, to get a required DFT, and to get how much spreading area is required. That's everything is depends on the volume of solid. If you are adding thinner, then you have to calculate newly the what will be your corrected volume solids, what will be your corrected WFT, what will be your corrected to get a required DFT. Yeah, and to calculate the your paint required, you have to calculate the waste also. Then 100 minus the wastage, then also it will give you the quantity of paint required. I think when you are applying your industry, when you are giving contract to applying paint to contractor normally used to they are trying to make the owner full by adding thinner in the paint, and then they are going to show you the wet film thickness, but your volume solid will, when you are adding thinner, your volume solid will certainly reduce, but they will prove, they will give you the same WFT, wet film thickness, but you will not get the DFT. That's why the thickness measurement, DFT, WFT, is very important, and that also give you the whether they are using some thinner or not, that you can come to know. When you are issuing some paint to a painter, whether he is adding thinner or not, that you can calculate very well when you are measuring the WFT or DFT. You can come to know if they use thinner, then your for the same WFT you will get lesser DFT. Lesser DFT. So that is very important to specify. You can calculate the whether your painter is make you full or not. So you can directly catch hold of the painter. That's why the solid volume is very important to know it is clearly. So friends, I have discussed what is the importance, earlier proposed importance of WFT and DFT. Now we have discussed the volume solid volume, to know the quantity of steel, paint required to cover a certain area per liter. And if you are using thinner, then your WFT, again you have to calculate your WFT and your new coverage area to get the required DFT. If you are satisfied, you please give tick mark, and you recommend this this topic, this channel so that you will going to get all sorts of knowledge, not regarding paints and others topic also, and you can spread this channel to your friends, to a graduate engineer trainee, and experienced person in the industry. They will be certainly be benefited. Okay, thank you very much.